Okay, good evening, guys. Welcome to the TDXS October 2024 meeting. We are blessed to have not one, but two programs for tonight. So without any ado, I'm going to just kick it right over to Roby to do the first one. Tell us everything we need to know about peak envelope power.
Okay, let me share the screen and I'll be happy to do so.
Okay, there you go.
Okay, so as I usually do, I make programs out of things that I'm kind of investigating. And I had a discussion with a guy. We talked long and hard about what peak envelope power meant. And he had lots of misconceptions. So I just tried to condense what I found. And that's what I'll talk about today. So just a brief review what power is. Power is the amount of energy transferred or converted from one form to the other during a certain unit of time. The standard measure for that we use in the electrical world is power is the watt, which is a joule per second using the SI system of units. If you look at that from a mechanical point of view, it's usually talked about in foot-pounds per second or horsepower in the standard British system. 1 watt's 746, or 1 horsepower, 746 watts. So for
What kind of horse?
to calculate, go ahead.
What kind of horse is that?
A Shire,
Okay, there you go.
to be precise. With direct current, power is pretty easy to calculate. Voltage times current, voltage in volts, amperes in current in amps. For alternating power, it's a little more complicated, and I'm staying away from anything other than anything other than resistive loads, staying away from power factor or any of that sort of stuff. So the instantaneous power is whatever the peak voltage is at the time times the current at that time into the load. And instantaneous power can be calculated any part of the cycle. But so alternating current's a little bit more difficult to understand, a little bit more difficult to handle. So the short method, since in our world we typically don't measure RF current, let me back up. So you can do power with one variable. You don't have to have both voltage and current. If you have resistive loads, you can just use voltage and the resistance of the load to calculate power. So for direct current, the voltage, you calculate power by squaring the voltage across the load and dividing it by its resistance. For alternating current, it's a little bit different. You take the peak voltage, square it, and divide it by 2 times the resistance. Now, I'm not going to go through the math to show that, but that is known as average power. So examples, simple examples, 12 volts across 50 ohms, 12 squared over 50 is 2.88. Little circuit diagram showing the convention for voltage and the waveform. So for calculating electric power in AC circuits, you look at the peak of the wave. This is the sine wave. There's the peak. So the average power produced over one cycle of this AC wave is the peak voltage squared divided by 2 times the resistance that the voltage is being impressed across. So just a simple example there, using peak voltage, a generator and a resistance. If you have 250 volts across 50 ohms, you produce about 625 watts. So with radio frequency, when talking about radio frequency power, we have to include modulation, because modulation is how we convey the energy. or how we convey the information. So RF power is generated by a transmitter, is modulated to convey information, whether it be a voice or whatever it might be. So there's several types, general classes of modulation. One of them is on-off. You either have the power or you don't. And that's typically what we see with Morse code. And in our world, we call it CW. You can vary the phase or frequency of the modulation, and that's what we call FM. Actually, varying the phase is called phase modulation, but there's very little difference between the two. And you can vary the amplitude, and that gives you amplitude modulation. And there's several kinds of that. The standard old amplitude modulation with a full carrier, single sideband suppressed carrier, single sideband reduced carrier, it goes on and on and on. A million different kinds of amplitude modulation. Each type of modulation produces an envelope, and that envelope is characterized by several things, but one thing it's characterized by is its minimum and maximum voltages. And the maximum voltage of that envelope, I'm going to refer to as V peak. So this is a picture, thanks to Mr. Hiller, a picture of a couple of different types of modulation. So this is continuous wave modulation, where we turn on and off the carrier to transmit what we want to say. The characteristic of this that's interesting is when it's on, the magnitude or the peak value is constant, does not change. Now, if you look in detail at a CW waveform, that's not totally true, but it changes on the front and the end a little bit, particularly if you have a poorly keyed transmitter.
Jesus Christ. Come on, let's go. Come on, go.
Okay.
Fuck. God damn it.
Rick, you need to mute there, buddy.
So
You
the
may not realize it.
the FM modulation envelope is very similar to CW in one respect, and that its magnitude is constant. The frequency or phase varies in this case, but for our purposes of talking about power, the thing that's really important is the amplitude. Now, when you look at a waveform that is amplitude modulated, you get a variable maximum amplitude. If you look at sideband, and this is kind of like a sideband envelope, partially modulated. Here's your peak, and you have a minimum. Actually, with sideband and properly adjusted, your minimum will actually go to zero, but that's another story. So this is the important part here is the peak amplitude. If you have an AM signal, you have a maximum and a minimum that's far from zero, but the important point is just the maximum amplitude. So the definition this is from the FCC rules and regulations. The definition of PEP, or peak envelope power, is the average power supplied to the antenna transmission line by a transmitter during one RF cycle at the crest of the modulation envelope, and it says under normal operating conditions. So this is the crest or the peak of the modulation envelope. So at this point, we would take this voltage and divide it and square it and divide it by 2 times the resistance that this voltage is being impressed over to calculate the peak envelope power. And just toss this in for grins. An amateur station is supposed to only use the power that's necessary to carry out the desired communications. And our maximum limit is 1.5 kilowatts PEP. There are some lower limits on certain bands and certain frequencies and that sort of thing. But the calculation of the concept of peak envelope power remains the same. So I was just throw this out here to show you, if you had a 50 ohm load and you were going to put 1500 watts into it, what voltage would be across it? So you just do reverse the algebra, and it turns out to be 387.3 volts. And in case you haven't thought about it, that can be lethal. So you need to be careful if you're around a load that is to which 1.5 kilowatts is being delivered, an antenna in particular. So this definition, this peak envelope power, kind of the summary, this definition is very precise, and it applies to all kinds of modulation. So if you go back and well, I think I've got this in here. So if not, I'll go back and explain it. The peak envelope power depends on the peak voltage at the crest of the modulation envelope. So if you look at these two, here's two examples. An amplitude modulated envelope, and I took a FM envelope. These two, if they have the same peak voltage of 387 volts, the peak envelope power is exactly the same. It does not matter what, because that's just by the definition. Now, those two types of modulation deliver the same peak envelope power. They deliver substantially different. I go too far. These two waveforms that have the same peak envelope power, they deliver substantially different long-term power to their load. And long-term power is averaged over several seconds. If you take this time scale from here to here, you'd see that there's substantially more energy contained in this waveform than there is in this waveform. So that's where the long-term average is very significant when looking at equipment rating and stuff like that. So why is it important? All components contain resistive elements. So you have resistive losses in the components. So if you take a capacitor and you pass a large amount of current through it that would be indicative of, say, 1.5 kilowatts, that capacitor is going to heat up. And it's going to heat up because of its internal resistance. And when it heats up, you can if its design is such that it can't dissipate the heat that's being produced by it, components can melt. The solder that holds it together can melt and flow, and you become an open circuit. The material that makes up the dielectric, when it's heated, its properties can change. So you can destroy capacitors with large amounts of RF power. Because these elements are metals, they expand and contract whenever they heat and cool. So if you have various heating and cooling cycles, you can actually cause things to fracture. Metals have there's properties of metals where you can bend them. You can bend them so far, but if you bend them further, you can actually take them to failure. You have dielectric failure due to high voltages. So if with a 387 volts across a 50 ohm load, if you have an intermittent connection to your antenna and you're transmitting that power and your connection goes intermittent or opens, you reflect twice that voltage back towards your transmitter or back towards your amplifier, whatever kind of device you're talking about. So you can get pretty substantial voltages due to that. Another thing that I've experienced myself in doing some magnetic design for inductors and the like, the inductance of a ferrite or a powdered iron core is a property of the, is a property of the materials that it's made up of, and it changes with temperature. There's a temperature called the Curie temperature, and when you get the material to that point, it basically loses its magnetic properties. They go substantially toward air. So I had a set of, had a tuner that I built. I was working with it. And when I run it for a period of time, everything was great. And when I kept transmitting into it longer, all of a sudden, everything just went to, hell in the handbasket, as they say. But when it would cool down, it would work just fine. And I did a little bit of troubleshooting, and I found out one of my inductors was heating past the point where its properties change. They also would change due to flux density, but so to continue my summary, peak envelope power alone does not provide an adequate basis for rating equipment. I have an MFJ tuner here that you guys can't see because I have it squirreled away. It was given to me by a guy because it failed. It would no longer work. It's one of the big 1.5 kilowatt jobs. It has a small sliding contact in it. And I am certain that tuner is fine for 1.5 kilowatts PEP with sideband and the relatively short or relatively small amount of average energy that a sideband signal produces. But the guy that owned it before it was fine, worked fine with him till he learned about FT8. And he started running FT8 with it, and it burned up that little sliding contact. Now, I had a heck of a time fixing it, but I finally got it working. But I wouldn't put more than a couple hundred watts through it on with something like FM or FT8 or Q65 or one of
Or RTTY.
those other modes. There's a lot of talk about duty cycle and that sort of thing. I could not find any standard for duty cycle related to RF power. I looked in all kinds of books and all kinds of information, all kinds of online information to try to find that. I see people calculate it different ways. Some people will tell you that an FT8 signal has 100% duty cycle, and some that will tell you it has a 46.5% duty cycle. And it depends on what you take as the time base for the duty cycle. So duty cycle really is too ambiguous to be very meaningful. And so all of this leads me to be skeptical of manufacturers' claims. So you have to look for other information. And this is one piece of information that I found. I did not find a lot of other information, even though I did look a bit. This is out of the KPA 1500 user manual. It says that for 100% duty cycle modes like FM, radio, and so on and so forth. I see this thing is hiding up here. I got to move it so I can read.
Back up.
Okay. So it's 5 minutes down, heat down, and 5 minutes to cool off at 1500 watts, which is pretty substantial. So if it'll do 1500 watts at 5 minutes, I'm certain it'll do 1500 watts at 12.5 seconds for FT8. At 50 megahertz, it's only 50 seconds. And I guess that has to do with the efficiency of the filter elements and the amplifier transformers and all the other stuff that's in it. I looked at several other manufacturers, and I did not find any comparable information. I will make one other comment, just as this right here, ICAS, intermittent, commercial, and amateur service. Intermittent is a key word here. 5 minutes is intermittent. What's the other one? CCS, I believe it is. Continuous commercial service. You start it up and turn it on on October the 16th, 2024, and you take it out of service for maintenance and cleaning and the like 2 years or 3 years later. That's the difference between the continuous commercial service rating and the ICAS rating. These ratings don't have much use anymore because they're all developed for tubes, and it really has to do with the cooling of the tube. Okay.
Yeah, I
Questions,
noticed
comments?
Can you hear me? I noticed it says you have to wait. If you leave it key down for 5 minutes, you got to wait 5 minutes in receive mode. So that's what the intermittent part is. Huh?
Yeah. So
K3LR told me last week, a couple of weekends ago rather, that DX Engineering is still selling lots of good sales, and amplifiers are leading the pack because people are blowing their amplifiers up on FT8. And one of the
Oh my God.
key reasons is you can do this maximum 5 minutes key down, 5 minutes, and 5 minutes receive, which is like 15 seconds key down, 15 seconds receive in FT8. But that's if you have a 50 ohm load. If you have high SWR, that's derated significantly. And so you might want to talk about the effect of being away from 50 ohms and what that means.
Well, doesn't that, Dave, doesn't that also
you get away
depend
from 50
on,
ohms, you have
well, sorry about the delay. I was just going to ask a question related to that is, doesn't some of that depend on whether you've got a match tuner behind the amp? Is that reactive current getting is it getting handled by the tuner, or is it getting handled by the finals in the amps?
Right.
Well, I think that's the point that Dave's making, and I think it does make a difference. But this is the rating, and if you're going to buy an amplifier, I can't comment on what Elecraft, how they did their design and what their rating is, other than this, because this is the only published information I've ever seen. They don't discuss other, performance at other loads and the like, at least that I have found.
Right. There's an assumption, I think, that that's a 50 ohm load.
Yeah, that's the point is people make lots of assumptions. And if I can talk about this one, the guy that messed up his tuner and ended up giving it to me because he didn't know what to do with it. He thought that PEP, that the amplifier was rated for 1500 watts PEP using a waveform like this. He did not consider or even understand that there was so much more energy transmitted through average energy transmitted through that tuner whenever he went to a mode like FT8. And the thing that, that's the element, because all of your components are going to be stressed like this through your I²R losses, through the higher voltage that's impressed across them. And you can even cause a coil to fail by putting enough voltage across it. The distance between the turns can develop sufficient voltage so they will actually arc over from a turn to turn, have a turn to turn short. Yes, sir.
Question. Yeah, a quick question while you're on this particular slide. You made some comments about the magnetic core failures. I thought that the story on ferrite cores was that once they had been thermally stressed, they did not ever return back to their specifications. Is that correct or not?
I thought so too,
Okay.
Bill.
Depends on the temperature.
Well, the reason I asked, well, so I've got a friend here, KR4LO, does a lot of RIDI, and he was in a RIDI contest last fall, and he smoked this 49-to-1 balun that was in this end-fed half-wave antenna that he had, and so in our looking around, he built another one with more ferrites, more toroids used in the winding. But from our reading, I thought the deal was that once that core has been heated above the Curie temperature, whatever the term is, I thought that was permanent. Could you comment on that, please?
So you are correct with Curie temperature. But when you do this, if you experiment with this, you will find that it starts changing before it reaches the Curie temperature.
Permanent change or
Permanent change.
Becomes lossy.
so don't toast your ferrite.
That's right.
No, and they're junk if you have.
Yeah.
So I've got, Roby, you guys might be interested in the possibility of doing this. I was just musing about you saying there's really no data out there about that. This could actually be done if you had if somebody wanted to do it and had either one of the gallon oil filled the old style dummy loads or a solid state
Dummy loads.
dummy load. If you were to set that in a bucket of water and put a thermometer in it, you could run CW at key down or whatever and sideband at key down, and you could look at the actual rate of increase of temperature of the water and convert that into
Power.
Into power. That somebody could do that. That would be a kind of a cool experiment to do.
Well, that's the traditional. Yeah, that would be the calorimeter method of measuring average power, right? I mean, I'm sure that's been done. I'm sure that's been done.
Yeah, so I don't know where the data are, but that would be something. You were saying you couldn't find it, but you could do that anytime you wanted to, or I could do it for that.
Well, that's only one time, and it's only good for one waveform. Now, when I talked about not being able to find data, I'm talking about being able to find data on the duty cycle. There is no standard for a duty cycle that I could find.
In the rules or just in usage, in everyday usage or in the FCC
in either place, Matt, I couldn't find anything. I looked at several people who've calculated it, and the FT8 duty cycle is a good example. It's not 15 seconds, it's 12 and a half seconds, followed by 1.5 seconds for decode time and 15 seconds till it starts to transmit again.
Yeah.
You know, when you look at that. So several people calculated FT8 duty cycle as the 12 and a half seconds that it was on and said it's 100%. Some people used 15 and 15 and said, hey, it's 50%. Some people use 12 and a half and whatever it is, 16 and a half and said it's 46 and whatever that fraction comes out to be, 46%. If you look at the waveform on sideband, well, I mean, and if you look at CW for a duty cycle, it depends on it depends on your spacing of your dots and dashes, your spacing of your words, that sort of thing. If you look at sideband, it depends on your voice. It depends on how long you talk, and the spacing between your words. It'd be very difficult to come up with something that would be meaningful. You'd have to come up with something that you could repeat consistently to have a true duty cycle.
You can have the cycle pretty high if you say "Hola."
Hola.
Well, I mean, that's so you used to look at the tube, the envelope of a tube, and do that and see it glow nice and red, right?
Right.
That was a cool thing to do in the day.
I was going to say my first lesson on duty cycle was the first time I had 811As when I was a pup. I learned pretty quick. You got to pay attention to duty cycle, or next thing you know, you got holes in your anodes. But to your point, Robbie, you know why I still got them, some old home built solid state amps that use the 2879As. And so on peak, those things pull about 150 amps. But when I would take them out and I built them for field operations and mobile operation because they run on 12-volt car batteries. And I found that, like in a contest, my overall duty cycle between transmit and receive and so forth, I only needed about a 20 amp charger to keep up with the load, even though the instantaneous peak was what,
Yeah,
six, seven times that?
yeah.
Cool.
Anyway,
How,
I find
how
What?
when did they go from, you know, there used to be was the limitation was on the input power, and then they FCC changed
okay.
it
So
to the
that
output
occurred.
power.
Yeah, so that occurred in 1978.
Uh-huh.
When part of the research I did this, I found that I was going to include something about that, but I decided not to not to let this thing get too long and focus on just a few points here. But it occurred in 1978. Prior to
It's
1978, the limit was, I found this very interesting. The limit was
1 kW, right?
kilowatt DC
interesting.
input power. Yeah, 1 kilowatt, right? Except if you had 1 kilowatt on your final amplifier and it was 100% plate modulated, your instantaneous power was 4 kilowatts. But they knew that, right? I mean, that's the way plate modulation works.
Worked. Yeah.
So today, if you take your modern transceiver like my K3, or somewhat modern, not too terribly old transceiver, if you put it on AM, you're limited to 25 watts. That's because whenever it peaks up, the peak power is 4 times that, is 100 watts. And that's about
Right.
what this amplifier will deliver. I found that pretty interesting.
Yeah, some of that old gear was um, rated at the input power and not the output power. And so I had a buddy he said, well, man, I got a 1 kilowatt tuner. Why am I having troubles with it? And because he was arcing it over. And I said, well, yeah, that's 1 kilowatt input, not output.
Interesting.
And so what if you had 1 kilowatt
Hmm.
in, what a class C efficiency somewhere in
He,
the 70% range, right?
well, he was running it behind a SB 220,
Yeah.
which was putting out, I don't know, 1,000, 1,200 watts. And it was arcing over when anyway, yeah,
That's cool.
very
Well, that's why I
interesting.
talked a little bit about what's the voltage level involved, to kind of calculate that, 387 volts. And if you have, like I said, if you have reflected power, it's even higher than that.
Right. When I was building those uh surge arresters, I had to select or choose what voltage rating to get the the gas tube in them, right?
Mm-hmm.
And so and then even at that, right? So like when you look at the ratings of the device, it's the like say I ended up with 50, I think 1,500 volts what I selected because it said just because of the variance and components, the low end they guaranteed was 1,200 volts at one arc. Um, but yeah, that's what I had to do was take, okay, well, I'm going to run legal limit. I want a legal limit protector, but I know I'm going to have some SWR on that line. How much, how much do I want to allow for? So it was from your 387 to the 1,200, and I figured, okay, well, I can live with that because I'm a resident antenna guy anyway. I don't like ISWRs,
Yeah.
but
And and
Yeah,
the
but if you like forget, go from 80-meter phone down to 80-meter CW,
oops,
you might be 5 to 1, right?
right.
So you gotta think about the human error side of it.
Yeah.
and the thing that we're talking about here, these are continuous voltages. Whenever you look at the capacitive reactance and inductive reactance in these circuits, the transient voltages are likely higher. Those are things you will never see except for one cycle, but that's all it's gonna take to cause your
Yeah, to
tube to
fire
break
that
over,
too.
right?
Yeah, right. That's right. Yeah.
Lots
So
of
you want some,
interesting things, right?
yeah, right. So you want some headroom.
You want some headroom.
Hey, what is,
That's why I have an Alpha 77 DX. Sorry, I don't. But
I
that
thought
was
that
the
was
old
those.
joke.
I thought
We
that.
need, if it's a two-holer, you got a two-holer for headroom.
Right.
Yes.
Yeah.
So if
What was the, yeah, guys, what was the, which was the company that used to advertise in QST with a picture of a skeleton sitting at the amp with with its arm on the key and said key down forever? Which was that, Alpha, or who was that?
That's
Anybody
two,
remember?
Alpha.
Dick
Alpha.
Garhorn.
I think it's Alpha, ETO. Yeah,
Yeah, Dick's company.
ETO.
That was a great ad.
Yeah, I have to find a copy of that one on the internet.
so
Yeah.
if any of you guys are members of the AMPS reflector, there's a guy who builds RF power amplifiers commercially for labs and that sort of stuff. And he currently has his what is it? Is that the 4CX 6000A?
Oh
His
my.
15,000 watt 6 meter amplifier. And he shows every 3 or 4 weeks, he comes out with a new YouTube video about, well, I'm building, this is the input circuit. This is the output circuit. Here's my power supply. And, the tube's about like a gallon milk jug or so. I don't know. I've never seen a picture of the tube, but, it's a big animal, right? I think it draws, 57 amps filament current or some such number as that. Yeah, we're going on. So what other questions? I'll do my best to answer, and hopefully this has been useful for you, so we can get on to Dave's presentation.
Yeah. Yeah, I got one, Roby.
Okay.
First off, let me apologize for my outburst there. I have a neighbor that's got dogs that they only respond to swearing. So, and I didn't even realize I had a mic on. So sorry about that, guys. Two things. You come across all these voltages you're throwing out here, which is a great thing, but you got to worry about the coax you use, because a coax does have a tolerance and a peak breakdown voltage associated with it. So, when you're looking at the overall system, that's one thing to look at. So have you looked at how you measure this stuff? What's the best or a good power meter to measure this? Is it some MFJ device? Is it a LP100A? Is it the Alpha? Have you looked at any of that?
So I looked at that briefly, and it was kind of a deep subject, so I didn't spend a lot of time on it. But one surefire way would be to use a cathode, use an oscilloscope and measure the voltage across the load. And for ham frequencies, HF frequencies anyway, 100 megahertz oscilloscope would be perfect.
Yeah, that'll do it. Sure.
That would do it. Now, if you go back and if you look at, go back and look at my waveform here. If you look at this waveform, there's a rule about digital sampling to get good data.
Nyquist.
Nyquist,
yeah. The sampling frequency. So, here I am. I'm designing my watt meter, and I'm going to sample here and here and here and here and here. No power, right?
Widely varying results.
Yeah, but the Nyquist criteria says if you sample it frequently enough, you can get a good representation of what this wave looks like. And it's I forget the number. I used to know that kind of stuff, but say 10 or 20 times the frequency of this wave. If you sample it that often, you can get a very good representation of the wave. So I think that is the way that the high-end digital meters do it. I'm not sure, but I would suspect that that's. I would expect.
You're right.
Expect that's the case, of course. And if you're looking at, get to the right place here. If you're looking at waveforms like this, if this waveform were constant, just the regular old RF or RF watt meter it will rise up and pick this level eventually, The problem with things like sideband is, can it follow this change? And that's why your old watt meters, you know, you would read something lower than your peak envelope power because the meter, the physical
Yeah,
um,
the
you know,
D'Arcy ball.
inertia in the meter could not
Sure.
follow.
Right.
Yeah, it just couldn't follow it. So
Even though
and
you
then
put,
another
go ahead, sorry.
so a trick would be to to rectify this voltage and put a capacitor in there and let the capacitor charge up as this voltage went up, right? And that's pretty good at up to a certain frequency, but then it seems to not work at really high frequencies. And then you can put an amplifier behind that with a hold circuit, you know, that will actually detect when the voltage gets up to, you know, till it stops increasing and hold that value, whatever that value is. And there's ways to do that electronically. So there's several methods that all should be pretty good. But it's a really interesting subject, and I think it would, you know, you could do a whole program on nothing but that. You could do a whole bunch of study on nothing but that.
That's next month, huh?
Yeah.
Yeah, we can do that later.
Get after it, Roby.
And Rick, thanks for the graphics. I really appreciate them.
Okay, thanks,
Oh,
Robbie.
anytime.
Thanks, Robbie.
That was good, Robbie.
Thank you.
Dave, do you have enough time left?
Beg your pardon?
Do you have enough time left?
Sure. If everybody else wants to hang around for it.
Did
All
I
right.
stop sharing?
You did.
Yes.
Is it my turn to share?
Yes, sir.
Okay. Can you see?
Looks good.
All
That's
right.
fine. Looks good.
Excellent. Okay, so this is strategies for increasing your DX contest multiplier count. This comes after a discussion I had offline with Roby over email. He said, "What do you think? How would I increase this?" And I told him a bunch of stuff, and he said, "Yeah, I do all that." But I thought maybe some of y'all don't know that, so I'm going to share. Let's see, how do I get to the next slide? So start from the basics. Contesting is about making QSOs. More contacts is more fun, and if it's worth doing, it's worth overdoing, as Mike would say. Our friend Mike up in B-Dive. Contest rules define the scoring. So, you know, competition between operators all over the place to generate a score computed from the number of valid contacts and the locations contacted, typically, in a particular time period. So the calculation is typically of the form score equals QSO points times multiplier. And the points, you know, points could be no points outside the target. Like if you're not working New Hampshire or doing the New Hampshire QSO party, then you're not getting any points in that contest. Or it could be distance based. For example, in this coming weekend, the CQ Worldwide, if you work a North American station, if he's a W, you get no points because that's not the target. Your target is to work DX. But if you work North Americans like Canada, there are 2 points. And if you work outside of North America like Japan or Europe, that's 3 points. All right. And multiplier types. This is important for the discussion later. In domestic contests, it's typically states, provinces, sections, counties. For DX, it's typically countries, or it could be zones, or it could be prefixes. And it may be counted per band or per contest. And sometimes it's a combination of them. And you know that operating categories are single op or multi-op. So the scope of this discussion, I'm focusing on the unassisted single operator, how to get your multiplier up, besides having a faster internet pipe for your cluster connection. In DX contests, because the two biggest ones of the year are coming up, Worldwide Phone and Worldwide CW the month later, the little pistol station, and part-time operation. So this is as much time as you want to put in, but not the whole weekend. And the little pistol station is a competitive station, but not a big gun. All right. So operators make the QSOs, and the biggest factor in your score is still QSO points. So the key to that is rate, and as Danny says, rate is king. Remember that when you're talking contesting. So if rate is king, how much should you worry about multipliers? Multiplier QSOs raise the value of all of your QSOs. And if multipliers are scarce or few, then the incremental impact is greater. In the November SS, there's only possible 80 some sections. What, 83, I think now? So that last section is worth a lot relative to another multiplier in WPX. And WPX, every other contact, or even more than every other contact, is a multiplier because there's so many prefixes and they're easy to come by. So these are some band, I shouldn't say band because I crossed out the bands, but this is the total QSOs, total prefixes for Roby in 3 different contests. WPX, where you can see 800 Qs and 450 prefixes. ARRLDX, where there's about a quarter, right? 260 out of 1,000. That was a really good performance there, Roby. And in November SS, 500 Qs, 80 sections. And typically, multipliers may call you, especially like in WPX. But the focus of your search and pouncing effort is first on mults. So if you're getting answers but not enough mults and you think there's room to find some multipliers, you're going to search and pounce and you're going to be mainly thinking, I want to find mults. And if you're having the opportunity to run, that's your only focus. I want to find mults and then I'm going to go back to running. If you're not running, when you go to a band, you want to find the mults that are there as fast as you can and then think about increasing your number of contacts with non-mults. So this next weekend is the Worldwide DX sideband, and a month later is CW. They're the biggest DX contests of the year, tens of thousands of people on the air. I think they're the most fun you can have on the radio. And the characteristics of the rules are your multiplier is countries plus zones per band. The countries are basically DXCC plus a few additional countries that the Worked All Europe contest includes. And the CQ zones, zones 1 through 40. So that's important. Some multipliers will be your first zone and your first of that country. We call those double dingers. So I'm going to give you several strategies with the single op, not using the cluster, and with a limited station. Let's see. I meant to say earlier, if I say something you didn't catch or you want to talk about it, go ahead and interrupt me. All right. So the first strategy is get the easy mults. You feel really dumb if you finish the contest and on 80 meters you didn't work your own zone, right? Because you could have done that with a wet noodle. So get the low-hanging fruit on every band, especially the North American zones and countries, and find a way to get on all bands, even if with a puny antenna, because it's not that hard to work on 160 a local, no matter what your antenna is, right? So that's the idea there. This is an example from Roby's log, that ARRL DX contest. He managed to work quite a few mults and probably got a lot of those easy mults here on 80. He only made 19 contacts, 15 of them were mults. That's good. Now on 10 meters, where conditions were easier, right? He made a lot more contacts than mults, but he also made more mults. So these 15 are probably represented on every band because he did a good job of spreading it around. Strategy number 2, much of the low-hanging fruit, besides working your own zone and maybe all the North American zones, 3, 4, 5, right? The easy ones, the W zones, is the mulch to the southeast, the Caribbean, Central America, South America. And if you have a rotating antenna, if you want to find those guys, put the ends of the elements toward the northeast to reduce the signals from the northeast, East Coast and Europe, and to enhance the signals to the southeast, and scan the band for stronger signals. And one of the tips for that is to cut your RF gain back so the stronger signals stand out. And you'll be surprised how many guys are there to work. And you do this periodically during the day, and most especially when the East Coast is busy running Europe, because the guys down southeast are not as busy when the Europeans are in, typically, unless they have really good antennas and they're beaming Europe and working Europeans that are covering you up. But it all depends, right? This is especially true when it's the ARRLDX, and the only people they have to work are North American stations. So it's less so, I guess, in CQ Worldwide. All right. Strategy number 3. And I think what you're going to find is a lot of these are, well, that makes sense. I should have thought of that, or I already knew that. But don't hang long in a pileup for a molt. You don't get through in 2 or 3 or maybe 4 tries. Stop. Go on. But when you go on, take advantage of your contest software and make a note of his frequency and call sign, because you've already found him. You don't need to go find him again. Make a note of his call and frequency, and the way they do that is with the band map, right? I think most of you are familiar with that feature of your contest software of choice. If he's a multiplier and he's got a pileup, come back in between 5 and 10 minutes to let the cluster pileup die down. Now in phone, you don't know who's going to spot them and when they're going to spot them. But typically, the RBN on CW tends to refresh spots about every 10 minutes. And what will happen is a guy will show up on a band, all the skimmers will find him, they'll all report him, and then for 10 minutes they won't report him, because that's their limit. They don't report over and over. They report 10 minutes later. So the RBN spots tend to have these little waveforms of kind of right when the spot's spotted, you get a few guys. Then as people realize it's there, there were a lot of guys calling them, and then it dies down a little bit, and then a new spot, and you get the same wave again, right? So give them 5 to 10 minutes. And the same thing goes for a non-multiplier QSO. After you think you've found most of the multipliers in the band, you've gone back to searching and pouncing for rate, but come back in just a minute or two, because even the 10,000 QSO guys call a lot of unanswered CQs, right? The guys that make world records still call a lot of CQs without an answer. That's interesting to know, because you feel like they're busy, right? But they're not that busy. They're busy, but they're not 100% duty cycle busy. Choose the best times to be on the air. And this seems simple too, but an experienced person is in a DX contest. If you're experienced, you're also probably an experienced DXer. You know when the bands are open where. And where are the big pools of available mults? Europe. There are more potential multipliers toward Europe and toward the east than there are toward the west. But you don't want to miss some of the easy things out to the west. The big pools of people are Japan, but there's also YBs now and VKZL that are easy to work. So you don't want to miss those. The point is, be there when the OMs are on the air, and be there when the conditions are better. So if you know the conditions are going to be bad the first day, wait till Sunday. People won't be busy. And also conditions will be better for you. Strategy 4, again, work Europe. It's up to half of your multiplier. And run them if you can, because there are a lot of PA, Papa Alpha stations from the Netherlands, but you might not find one right away. They may call you, but they may miss you. So, rate tends to bring in multipliers, but but rate is only as good as your signal and your skill level. And when it comes to zones, some zones are hard to work. Even the biggest guns rarely get a sweep of all 40 zones, right? 34 is really hard to come by. But still, they're going to rejoice if they get anywhere up above 35. And the far away over the pole zones require more DXing skill and more signal. So your best bang for the buck is North America, your W6, your W5, and your W4. And Europe and Japan and the ones to the southeast that are easy to get. Let's see, I think I'm back. Yeah. Yeah, there we go. So strategy 5. This is something you can learn. What does a pileup look like and sound like? And I used to just say sound like because we didn't have waterfall displays, but now we have waterfall displays. If there's a crowd of several signals calling at the same time, it's likely a pileup, and therefore it's likely on a multiplier, right? So it has a particular look on your waterfall, and it also has a particular sound. So learning that sound, you can kind of quickly go through a band and find a pileup, find the pileups. And if you're strong enough, or if you have propagation favorability to that area where they're coming from, or he's coming from, you'll get through real quickly. But it may help you fill out the band map really quickly so that you can go click, click, click back and back through your search and pounce history and find them when they're not busy. You have to apply strategy 3. That was call 3 or 4 times and that's it. Also, there's the sound of a fluttery DX signal. One of the great fun things to do is to point your beam northeast when Europe is just really kind of closed on 10 or 15 and hear that fluttery signal of a Scandinavian or maybe a Russian coming in late in the auroral sporadic E. And they sound different. You'll know that's DX. It may not be a new one for you, but you'll know it's DX. So the strategy that goes along with this is you tune for pileups, you tune for multipliers, and try to get through the band quickly. Then if you need to be searching and pouncing longer, you can go through and work a little harder to distinguish the weak guys and sift the band more carefully. Does that make sense? I have and one of the cool things about tuning for pileups is you can, with the DXpeditions, we've had quite a few DXpeditions on, you can see what a pileup looks like when they're saying up 1 and everybody's found the last guy who worked. You can see what it looks like on your waterfall display. And you can also tune past it and go, okay, I hear multiple signals all at once. That's the kind of thing you're looking for to find a multiplier. And using that N1MM waterfall, well, I'll mention that in the next slide. Using your band map is good. The N1MM has a waterfall spectrum enhancement. This is the waterfall. It's showing signals going by. It's got frequencies overlaid. Here's where your receiver is right now. But notice these things. These are past spots that either came from the cluster or were entered by the operator. I found the signal here and it's KN5L. I found a signal here and it's SN5IMO. Or here's IK3WUZ. This is really nice because it allows you to tune and say, oh, I already heard that guy. And all you have to hear is just a little bit of information that confirms that it's that guy. That's very helpful. So, but here the strategy is not about the band map. It's really about your big knob turning speed. The big knob on your radio that we're rapidly training ourselves not to use by using the cluster is what you're going to use a lot if you're single op and not assisted. So increasing your ability to figure out quickly who is on a given frequency is a skill that really makes a big difference in your contest scores. You want to be able to figure it out before the next guy does, so you can pounce right away or move on quickly to the next guy. The best way to practice that is to ignore the cluster, turn it off, or close those windows so you're not looking at, RA1DX is on 14023, and I'll go see what he sounds like. And CT1BJQ is on 28. And I'll go see what he sounds like. See if I can hear him. Don't do that. Use the big knob and practice. It's a lost art, as some people say. It's sort of disappearing. Strategy number 7. Act like you're loud. At NR5M, who has probably the biggest station in Texas now, not used a lot, but it's still the biggest station in Texas. We used to have a saying that you can't be the loudest signal on the band if you're not
transmitting. Right on. I
Right.
remember that.
I knew you would remember that, Tuna. But here's another thing. When the frequency is clear, you are the loudest station on the frequency, even if you're running 5 watts, right? So if there's propagation enough for them to hear you at all, and nobody else is calling, you're the loudest station. So act like it. Don't act like you're weak. Act like you're loud. That doesn't mean you're not going to be, you're not going to apply the skills of just knowing just when to call, as opposed to just slamming your call in there and expecting them to come back because you're a big gun. But remember that when nobody else is calling, you're loud. Another thing is QSB happens even to the loud guys. So if you're only a couple of S units down from a loud guy, say you've got a good beam and the other guy has a good beam, and he's running a kilowatt and you're running 200 watts, you're not that many S units down. And if the QSB is 2 or 3 S units, well, you might clobber him, right? You might bust that pile up right over him, even though he's running a kilowatt. And the practice for this is practice your pilot busting skills with the DXpeditions. You may not be trying to fill out all the band slots for C21mm, but you can practice when you find them on 15, and you can look up at the wall and see you already have a card for that. But you can still work them and practice your pilot busting skills. Also, smaller contests that are frequent, like the CWT, there are little mini pileups on the loud guys calling CQ, oftentimes. And so you can practice recognizing on CW, that's what that contest is, recognizing when you're doubling with somebody in the pileup, and getting a feel for if the DX station or the target station doesn't come back to you right away. Is he thinking, who did I hear? And maybe you need to repeat it or not. And so there's no substitute for practice on the air to raise your skill level. So those are the 7 strategies that I talked about with Roby, put into a presentation for you guys. Any questions so far?
Yeah, I've got one.
Go ahead.
Yeah, Dave, could you comment about what you think in terms of DX ops and their code speed? Do they tend to be going really like blazes, or some of them doing, going slow. I've always thought that my opinion has always been that the guys who are doing 30 or 32 words a minute are probably the better ops. What's your opinion about that?
Yeah, typically. But you can tell if they're actually copying people correctly or not, whether their skill level is up to the speed that they're running. Uh, and uh, my strategy is if the pileup is big and I think I'm loud enough to break it, I'm going to slow down. Because the ability of the human brain to pick out a particular note in a mix of notes is enhanced by the duration of the note. It's something K5RC taught me many, many years ago. I didn't realize it. I mean, he taught me that strategy, and I didn't realize why it works that way. But if your tone is constant for a little longer, then the operator's brain can distinguish it from the other notes around it because the pileup. And another thing that I didn't mention, I probably should have, is be sure not to call zero beat. If you call zero beat and there's a packet pileup going on with two or three other guys that are calling zero beat, what the operator at the other end hears is I can't
Right.
hear any dits or dots. But if you call a little bit lower, he's going to copy you through that carrier of two or three guys that are calling on his frequency. So there are ways to do that automatically with some of the contest software. It'll automatically variably move you up and down from the frequency you select on your band map. But always tune them a little high or a little low, whatever your preference is. And you'll be amazed how much better you get through. Packet pileups are a scourge.
Dave,
Yeah. Go ahead, Doug. Go ahead, Roby.
one thing I saw in a recent RIDI contest that relates to that is I had my filters in RIDI set up so sharp that when these guys would do that, I would actually lose them.
Mm.
So after a while, after several instances of that sort of thing happening, I opened up my filter a little bit, which actually was better, and I had more contacts, with a little bit wider filter than I had with the really narrow one.
Yeah.
And RIDI's a little bit of you have I tune RIDI by sound. I can roll across it and I can hear when I'm going to copy it. And that was, that's something I found. But I'm not talking about a lot, right? I mean, we're talking about,
Well,
50 or 60, 70 hertz maybe.
yeah. Well, that's what the RIT is for.
Dave, could I get
thing.
you to follow up on another part? And that was, it's one thing to say on CW to go either a little above or a little below where everybody's zero beat with a guy. But how about on sideband? What's been your experience? Depending upon if you're on if you're on 20 and everybody's on upper sideband, should you slide high or slide low?
I wouldn't slide much at all,
Yeah.
right? On
That's-
sideband, it's more about your signal level and the timing.
Yep.
One of the cool things about sideband is sometimes one of your phonetics or a syllable or two will come through while the other guy or other guys are in between syllables, so to speak. And so your your objective there is to speak very clearly and have really good audio so that so that your voice cuts through. Yeah. And on phone, I'm less of a phone op than I am a CW op, but the key is oftentimes if you're the first one to get a letter in, Kilo 2 TNO, Tango Norway Oscar, if he hears the Kilo or the Kilo 2, he's tuned into you to hearing the rest of your call and to the voice that you sounded like when he heard the first letters. So being snappy is good. Your ability to tell whether somebody on frequency or who that is and whether they're already in your log is and do it quickly can enable you to call sooner.
Yeah. And do not slow down on the phone.
No. There's
Just
not much
keep,
needed.
no, you slow down and it's like you'll get stuck on
So,
a letter and he'll do it 5 times. And that's like, no, just tell me at regular talking speed. I don't need it, you know.
Right. That's part of acting like you're loud, right?
Right, right.
Right.
and
Even
Dave,
And don't use your last two letters,
no,
please,
no,
ever.
no. Say your whole call. Always say your whole call.
Yep.
I should have put that in there too. That's definitely an important thing. Chuck knows it takes 3 overs to get a QSO done when you could do it really fast if you just say the whole doggone call. And something else I didn't mention, we were talking about when to be on the air. If you're a little pistol, you'll find that the pileups are smaller on Sunday rather than Saturday. Uh, when 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 the DX stations are begging for contacts, they're booming in. They've got a clear frequency, but nobody's calling them. That's a great time for a little pistol to get to make the contact. So if you can load your operating time onto Sunday, if you're willing to do that, that's also a good thing to do.
Yeah, that's a good one. You waste a lot of time getting mults on Saturday that you could just easily get on Sunday a lot of times.
Right. Right. Okay. So I'm gonna go on to the next slide. Just a little bit about ARRLSS, right? Even the big this because that's also in the next month we'll have 2 opportunities for sweepstakes. Even the big guns don't always get to sweep. So getting a sweep is not important, but every next multiplier is a pretty big deal. So 90% of the states have plenty of participants, and if you make a lot of QSOs, you'll talk to 90% of the states, 90% of the sections. But sometimes it's hard to find the guys that are close in, like Louisiana or Mississippi. So you can find them around sunset on 40 meters when you have short skip before the band goes long. And on 10 meters, you can find them on scatter right around sunset as well. That's the time when you can work, and they sound like locals. And of course, 80 meters all evening. North Dakota, South Dakota, they can be hard to get, but if you beam due north on 20, that's where you'll find them. The Northeast, Rhode Island, Vermont, Maine, VO1, VE1, they're hard to come by if 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 there's not somebody like VY2SS or VY2LI on. But 20 meters right at sunrise is when you can find those guys. And then 15 and 10 meters in the early morning when the band is not absorbed and the skip is long, we are screaming into that area from down here. And so you should be able to find them then. Northwest, there's a lot of hard ones out there like Wyoming or Idaho. So kind of as the band is closing to the east and you're beaming west, that's when you're going to find those guys. When you're not really working anybody to the east anymore, kind of at the end of the opening. So that's some clues about that. But the main thing is for all contests, is the more contacts you make, the more multipliers you'll have. And
Oh, Dave, let me add too that if you're missing like KP4, KP2, something like that, you Sunday morning on 10 meters, you're gonna find those guys.
absolutely right. If you didn't work them the first afternoon, yeah, that's right. But they're duck soup from here, right? As long as you find them. More questions? I'm pretty excited about this upcoming major season with all the sunspots. 10 meters is going to be a lot of fun. 20 meters is going to be a lot of fun in the evenings and at night, provided we don't have any crappy solar stuff, solar flare stuff. But on the good days in the last couple of weeks, signals have been just fantastic from all over. I tuned onto 10 meters. What was it? Yesterday I was out at Dennis's and taking a break before going up the tower after getting everything laid out. And I looked at the cluster, and there was 7Z1 Bravo Norway stroke Beacon on the list of stations it had heard on the RBN. And I said, I wonder who spotted that. So I moved the mouse over it, and it said a W9 had spotted it. So I tuned up there, and there's a 10-watt beacon from Saudi Arabia, and he had QSB, but he was up to S8, 9 on the peaks. And I'm thinking, oh, that's a really good sign. I'd love to see some of that during the contest next weekend. So conditions have been really fun. It's going to be a great, and one other thing is that good conditions bring out lots of participation and also lots of de-expeditions. So we've had a lot of de expeditions because they're taking advantage of the good conditions, but also the expeditions for contests will be a little bit more numerous.
Mhm.
So, as the immortal Edna Mode says in the Incredibles, go, fight, win, and call me in the next contest. I'd love to hear you on there.
That's great. Thanks, Dave.
Yeah, and don't forget about long path on 10 meters. It sometimes is more productive than short path to Asia, that is.
To Asia in the morning.
Yeah. Yeah, they're people. All I've got is a 20-foot high dipole on 6 meters, and I'm seeing all kinds of people working long path on 6. And I occasionally will copy them on FT8. It's amazing.
Well, there's nothing like
Yeah.
that. There's nothing like hearing something from far, far away. A lot of fun.
Okay, well, I guess it's the end of it. Thanks, guys. 2 really good presentations. Let's do that every month.
All right.
Well, we need more people to participate. We'd love to hear what you have to say or what you think. It's not so hard to put these things together. You need help. If you want to do something, you need help, let me know. I'll see what I can do for you. Even our discussion on the reflector regarding lock washers was pretty valuable. There's a lot of good information there, and there's lots of topics like that that'll broaden our ability to make contacts and either directly through operating techniques or through better equipment or less downtime or whatever it might be. Anything like that would be really welcome. Alan needs things for the bullsheet. We're trying to make this organization go, so each of you guys have got something that you could add and will make a significant contribution to our overall effort.
And by the way,
Roby?
if anybody wants to be president, VP of programs, secretary, treasurer, they're all open. So let me know.
Yeah. Quick comment about the lock washers story. Whatever. I was an unindicted co-conspirator in that exchange about lock washers in all kinds of information. It reminded me of a story about a little kid who got a book about penguins for his birthday, and a week later his mother asked him how he liked the book, and he said he thought it was great, but it was a hell of a lot more about penguins than he'd ever wanted to know.
Yeah.
Yep. I had an economics professor that said that, and he used a different thing. It's more about snails than you wanted to know about snails. Because he would get off on a tangent. And like 5 minutes later, you're going, I wonder how much of this is actually going to be on the test. And then he'd come out with that line, well, that was more about snails than you really wanted to know about snails. And you're scratching out everything he said because you're thinking, dadgummit, he's wasting my time.
Okay.
All right.
Good night, gentlemen.
This
Thanks
has
a
been
lot.
real. By the way, I'm trying to set up a tuna sighting for the November meeting. Phyllis and I are trying to come to Houston, and I'm hoping to be able to do it during the week of the 11th, 12th, during the week or during the contest. And so I will let a suitable announcement out about it, but I'm hoping to be able to be there and see some of you characters in person for the first time in a while. A year ago I was there and saw Chuck and Dave and some of the other guys, but I'm going to try to do it another time. Kim unfortunately be out of town, but he's volunteered to pick up the check for the meal, so that was nice of Kim.
Yeah, what I said was checks in the mail.
Anyway, I'll send out an announcement. I hope to be able to make an eyeball appearance.
That'd be great. Okay, good night, gentlemen.
Good night.
Good night.
All right.
Good night.
Good night, everyone.
73.
Great
See you
presentation.
later.
Thanks.